What this is saying, all right? Chebychev's theorem says at least 1 minus 1 over k squared of the numbers in a set must lie within k standard deviations of the mean. All right, well, first of all, what does this mean, k standard deviations of the mean? Okay? So let's look at data here, and let's say that this right here is our mean. Okay? And I don't know what value that is, but let's say, for example, that our standard deviation equaled 2. If I go up 2, I have added 1 standard deviation to the mean. And if I go down 2 from the mean, I've subtracted 1 standard deviation from the mean. That's whatever that value is. Okay? Now again, that's 1 standard deviation. If I were to, say, add 2 standard deviations, I would need to start at the mean and go up 2 and then up 2 more. This would be plus 2 standard deviations. Okay? And then here we have x bar minus 2 standard deviations. Alright, does that make sense? Yeah. Alright, so if x bar was, say, 50, then 1 standard deviation from the mean would range from 48 up to 52. And 2 standard deviations from the mean would go from 46 up to 54. Okay? Now, what Chebychev's theorem says is that if I'm looking at, say, 2 standard deviations, so 2 standard deviations, okay? Then at least 1 minus 1 over 2 squared of the data is going to be in this range from 46 to 54. Okay? So 1 over 2 squared is 1/4. 1 minus 1/4 would be 3/4. So at least 3/4 of my data okay, this is at least 3/4 of the data. All right? Does that make sense? So now, can it be more than 3/4? Yes, but at least 3/4 has to be in that range, is what Chebychev proved. Okay? If I went further and I looked at 3 standard deviations, okay? So now I go up 2 more. I'm at x bar plus 3 standard deviations, which would be 56. And if I went down 2 more to x bar minus 3 standard deviations, I'd be at 44. Okay? How much of the data would be in this range? Well, let's see. 3 standard deviations, that means k equals 3. So 1 minus 1 over 3 squared.
9.
Yeah, that's 1 minus 1/9. So 8/9. Okay? So I know at least, scooch this down a little bit so I can write, at least 8/9 of the data is in this range from 44 to 56. Okay. Change that. Doesn't match. Okay? Does anyone have a question about this now? Like I said, it's an easy one. It's an easy theorem mathematically, but it can be a little bit tricky to really understand at first. Okay? So, going back to this, it says we have 600 students. It says by the way, here's a little bit of language. It says the mean and standard deviation of 235 and 28 respectively. Okay? When you see that word respectively, that means that they've listed kind of pairs in a specific order. They said mean and standard deviation, then they said 235 and 28. So respectively means that mean is 235 and standard deviation is 28. They're in the same order that they were listed. Okay? So, I know that's sometimes a hard thing to make sure we keep straight. So our mean, 235, standard deviation is 28. Okay. We're going to use Chebychev's theorem to determine the intervals containing at least 3/4 and at least 8/9 of the scores. So first of all, how many standard deviations did we have for 3/4? 2. Okay, so for 3/4 of the scores, that was 2 standard deviations. So we're going to take this x bar, 235, and we're going to add and subtract 2 of those standard deviations. So 2 times 28 is 56. If we add 56 to 235, we get 291. If we subtract 56 from both, we get, I think it's 179. And we can write that as an interval like this. Any questions? Okay. So then for 8/9, how many standard deviations was that? 3. And by the way, I know we just found these, but this is where you would just have to start trying k's until you got 3/4 and 8/9. Okay? You just have to try it. So we're going to use 235 plus or minus 3 standard deviations. So that would go down to how much?
151.
Good, 151. And up to 319. So I know at least 8/9 or 88.9% of our data is going to fall in that range. Okay. Any questions?
The answer is the interval?
Yeah, the answers, what they're looking for are the intervals there. What would happen to the intervals if the standard deviation was 16 instead of 28? Yeah, they'd be narrower, smaller, okay? We'd only be adding or subtracting 32 here. And here we'd only be adding or subtracting 48. Okay, so we would narrow that range.
Could you do 34?
Yes. Yes. Okay. Any other questions on Chebychev's theorem before we look at 34? Okay, I'm going to stop this because I already